Welcome to Algebra for Success. In this segment, we're diving into a powerful problem-solving technique in algebra, systems of equations. Think of systems of equations as your secret weapon to tackle real-world problems with multiple unknowns. Let's explore them with examples and tips to guide you on your algebraic journey. Systems of equations are a collection of two or more equations with multiple variables. These systems are used when you need to find values for variables that satisfy more than one condition simultaneously. In most cases, you're looking for the point where the equations intersect. As I said before, solving systems of equations is a fundamental skill in algebra and mathematics. There are various methods to tackle this problem, each with its own strengths and weaknesses. We will cover two common methods for solving systems of equations, the substitution method and the crossover method, with examples for each. 1. Substitution method. The substitution method is a technique used to solve systems of equations by solving one equation for one variable and then substituting this expression into the other equation. This method is particularly useful when one equation is already solved for a single variable, making it easy to substitute that expression into the second equation. Example: consider the system of equations. Equation 1. 2x plus y equals 8. Equation 2. 3x minus 2y equals 1. Step 1. First, let's solve equation 1 for y in terms of x. This involves isolating y on one side of the equation. From equation 1, 2x plus y equals 8. Subtract 2x from both sides. Y equals 8 minus 2x. So you solve equation 1 for y, and now you have equation 3. Y equals 8 minus 2x. Step 2. Next, substitute the expression for y from equation 3 into equation 2. Equation 2. 3x minus 2y equals 1. Substitute the expression for y from equation 3 into equation 2. 3x minus 2 to 8 minus 2x equals 1. Step 3. Now you have a new equation with x as the only variable. 3x minus 16 plus 4x equals 1. Step 4. Simplify and combine like terms by adding 3x and 4x. 7x minus 16 equals 1. Step 5. To solve for x, isolate it on one side of the equation by adding 16 to both sides. 7x minus 16 plus 16 equals 1 plus 16. This simplifies to 7x equals 17. Step 6. Define x, divide both sides by 7. 7x divided by 7 equals 17 divided by 7. Simplify. X equals 17 divided by 7. Step 7. With x now known, you can find I by substituting the value of x into equation 3. Equation 3. Y equals 8 minus 2x. Substitute the value of x. Y equals 8 minus 2 multiplied by 17 divided by 7. Step 8. Simplify. Y equals 8 minus 34 divided by 7. Step 9. To subtract fractions, find a common denominator, which is 7 in this case. Y equals 56 divided by 7 minus 34 divided by 7. Step 10. Subtract the fractions. Y equals 56 minus 34 divided by 7. Y equals 22 divided by 7. Step 11. You found the values of x and y. X equals 17 divided by 7. Y equals 22 divided by 7. 2. Elimination method. The elimination method is a technique used to solve systems of linear equations by manipulating the equations in a way that allows you to eliminate one of the variables when you add or subtract the equations. This results in a simplified equation with only one variable, which you can then solve for. Example: consider the system of equations. Equation 1. 2x plus 3y equals 11. Equation 2. 4x minus 5y equals 3. Step 1. To begin solving the system, we aim to eliminate one of the variables. In this case, we'll eliminate the variable I. To do this, we need to manipulate the equations so that the coefficients of I in both equations become additive inverses of each other. This will cause I to cancel out when the equations are added. Step 2, we multiply both sides of equation 1 by 5 and equation 2 by 3, which will make the coefficients of y additive inverses. Multiplying equation 1 by 5. 5 multiplied by 2x plus 3y equals 5 multiplied by 11. This simplifies to 10x plus 15y equals 55. Multiplying equation 2 by 3. 3 multiplied by 4x minus 5y equals 3 multiplied by 3. This simplifies to 12x minus 15y equals 9. Step 3. Now both equations are modified. Modified equation 1, 10x plus 15y equals 55. Modified equation 2, 12x, 15y equals 9. Step 4. We add the two modified equations to eliminate y. 10x plus 15y plus 12x minus 15y equals 55 plus 9. This simplifies to 22x equals 64. Step 5. To isolate x, we divide both sides by 22. 22x divided by 22 equals 64 divided by 22. This simplifies to x equals 64 divided by 22. Simplifying further, x equals 32 divided by 11. Step 6. With x now known, we can substitute this value into one of the original equations, such as equation 1 to solve for y. 2 multiplied by 32 divided by 11 plus 3y equals 11. 64 divided by 11 plus 3y equals 11. To solve for y, we'll isolate y on one side. 3y equals 11 minus 64 divided by 11. 3y equals 121 divided by 11 minus 64 divided by 11. 3y equals 57 divided by 11. Now divide both sides by 3 to find y. 3i divided by 3 equals 57 divided by 11 divided by 3. Y equals 57 divided by 11 divided by 3. Y equals 19 divided by 11. Step 7. The solution to the system is the values of x and y. X equals 32 divided by 11. Y equals 19 divided by 11. Example 2. As the manager of both a lemonade stand and a cookie stand, you have two primary objectives. First, you want to produce a total of 35 items, a combination of lemonades and cookies, to meet the expected demand, and second, you aim to achieve a profit of $50. To accomplish these goals, you must take into account the price of each product. Each lemonade you sell generates $2 in revenue, while each cookie yields $1. These prices play a crucial role in determining your profit. The system of equations encapsulates your managerial aspirations. 1. 2L plus C equals 50. This equation addresses your profit target. It asserts that the total earnings from selling lemonades, symbolized by L, and cookies marked as C, must amount to $50. This is how you ensure that your business is not only covering its costs, but also generating the desired profit. 2. L plus C equals 35. This equation pertains to your production target. It emphasizes that the total quantity of lemonades and cookies you produce and sell should sum up to 35 items as determined by the demand for these products in your market. In essence, you are carefully balancing the number of items you produce 35 with the pricing of each product to reach your twin objectives of profit and quantity. You can solve this system using substitution or elimination methods. In this case, we'll use the elimination method. First, subtract the second equation from the first to eliminate C. 2L plus C minus L plus C equals 50 to 35. 2L minus L equals 15. Therefore, L equals 15. Now that you know L, which represents the number of lemonades, you can find C, which describes the number of cookies, using the second equation. L plus C equals 35, and L equals 15, therefore 15 plus C equals 35. C equals 35 minus 15, and the result is C equals 20. So to make a profit of $50, you need to sell 15 lemonades and 20 cookies. Here are 5 tips for success with systems of equations. 1. Choose your method. Decide whether to use the substitution or elimination method based on the system's complexity and your preference. 2. Maintain balance. When using the elimination method, ensure that the coefficients of one variable in both equations are additive inverses, one positive and one negative. 3. Check your solution. Always verify your solution by substituting the values back into both equations to ensure they satisfy both conditions. 4. Understand the problem. Systems of equations often arise in real-world scenarios, so understanding the context is crucial for solving them effectively. Systems of equations are your tools for solving complex problems involving multiple variables. They have applications in various fields, from business and economics to engineering and science. In our next segment, we'll explore inequalities, where you'll tackle problems that involve ranges of values, not just specific solutions. Until then, practice your skills with systems of equations and remember that algebra is all about finding solutions to real-world challenges. Keep practicing, keep learning, and you'll be well on your way to acing your algebra class. See you in the next segment.